A long talk because there's so many instruments. It's not because there's nothing to talk about. There's a long talk on the existing instruments, and it's a much shorter talk on the new instruments, not because there's that many fewer new instruments. There's plenty of new instruments coming, but I don't have any science result to show, so I will skip that. This is a picture that I like to show because it goes back to the very beginning of the VLT. This is in one of the very first VLT documents that shows you how the VLT can be used. It can be used as 4 individual telescopes, 4 8-meter telescopes that just look at wherever each of those telescopes looked at, but they can also be coupled together into the VLTI, in the interferometer, where all the telescopes look at the same object, of course, and then you combine the light coherently to get the spatial resolution, or you just use these 4 telescopes as light buckets and create sort of what's the equivalent of a 60-meter telescope, which is only happening now. Okay, we've never used it in this mode. We've used the VLTI for quite a few years already. This, of course, is the easy mode. Once you have a single telescope, you just start using it. But this is the new mode that Espresso will be exploring. I will talk a little bit about gravity and Matisse. Actually, I will talk about Matisse and not much about gravity. And then I will talk about the new instruments that are coming to the VLT individual telescopes, the UTs. So this is an image that you've now seen the 3rd time. This is the situation now. And the reason I put this up is because I'll show you the situation as we hope it will be in about 4 years' time. Okay, so we have I'm not sure whether I should call it luxury, but we have options at ESO. We have so many facilities that we can actually think about how to best use those facilities. And that's also something that the community should think about. How are you going to make best use of what's offered? Okay. The one thing that we want to do when the ELT is being built, or now as the ELT is being built, we need to safeguard the VLT and make sure that we can offer this to you for the next years with the best instrumentation that we can have. And that's what this talk is about. Okay, so we need to have the VLT, and that includes the interferometer, operational for, it says here, another 10 to 15 years. What that means is, we want to compete with everybody on this planet, at least for that long. I think we should actually compete for much longer than that. We have unique capabilities with VLTI. This is a capability that nobody else has at that level with this size of telescopes. And as I talked to somebody here in the room earlier on, this includes the 3.6 meter and the NTT telescopes on La Silla that you've heard, and also the 4-meter telescope on Paranal, the Vista telescope. This is the short version of what Henri showed you now at great length. Okay, I just put this up so you have a rough idea with what we're dealing with. There is a picture that's sort of floating around that shows you all the instruments, and Michael Sterzig showed you one of those, all the instruments in one image, and I find it frightening every time I see this. Now, this is just the names. In red are all the capabilities that Henri has talked about, and in white are things that are coming. Espresso, which is commissioned right now, being commissioned right now. This is a CRIRES upgrade. This is a near-infrared high-resolution spectrograph, which we're now turning into a Nichelle spectrograph. ERIS is a replacement for NACO, a much better instrument than NACO is or has been. MOON's a multi-object spectrograph in the red and the near-infrared. For the VLTI, we have Pioneer and Gravity working. Gravity working in the imaging mode. The astrometry mode is somewhat harder. They're still working on that. I'll show you Matisse, which is the new infrared VLTI imaging spectrograph, and I'll show you something about Foremost, which is an optical high multiplex spectrograph as well, just to give you sort of an idea where we are. Before I do this, I wanted to introduce you to something that has arrived on Paranal, something that we're using, that we're offering as of period 102 for the first time, and that's the Adaptive Optics Facility. The Adaptive Optics Facility has been a 15-year project. Okay, so ESO has worked for 15 years on this. We've taken one of those telescopes, UT4, out of operation for twice for 3 months to be able to install a new secondary, to install structures. And in the end, you have these boxes on the side of the telescope. So you have a new secondary mirror, which is a deformable mirror. And you have these boxes on the side, which are lasers. Each of these, here you see the lasers being shot into the sky, creating 4 artificial stars in the sky. And so we've made that investment for 3 instruments, essentially. So we have the laser guide stars. We have this deformable secondary mirror, which has about 1,200 actuators, works on a hertz level. And then we have these 3 combinations. So MUSE is this integral fluid spectrograph that Henri has presented to you and shown to you how it's used today. So you can use that in the natural seeing mode, no correction. But we have 2 modes that will make use of these lasers. One is called the wide field mode, and that has essentially a ground layer that corrects for ground layer turbulence, and it has the same field of view as the natural seeing mode, 60 by 60 arc seconds. And then we will commission, or we are commissioning right now, this new mode, this narrow field mode, which is optical laser tomography. That's a much higher correction, but as you see here, that's also a much smaller field. That's only 7 by 7 arc seconds squared. And then in addition, we have Hawkeye, which Henri has presented to you. Now we can now support Hawkeye as of period 102, it's offered. We support Hawkeye with a ground layer adaptive optics system that gives you a 7 by 7 arc minute field of view. I think that's the biggest one that is actually available to science. Just to show you, when you let engineers loose on the project, it can end up like this. I told you these 4 lasers create 4 stars. Now those guys have been able to control those stars, these beacons, in a way that they can actually, so each laser wrote a different letter. So one laser wrote A, the other one O, the third one F, and then the last one just did the star. So this is the AOF writing itself into the sky. It's just, we only want the point, okay? We don't want the letters, we want a point. But nevertheless, they can do that. So the adaptive optics facility is not an instrument itself. It's a facility that provides a better beam to the instruments. So that's I think how we have to think about this. And I won't dwell on this much more, but the wide field mode, we have a seeing enhancer, and it's a spectacular thing to use. So you all of a sudden, you get much better images than you get when you just look at the sky. And so that's extremely useful, both in the case of MUSE in the optical, so that's at 750 nanometers, for example, and also in the infrared with Hawkeye, where you have it in the infrared bands from 0.9 to 2.2 microns. And the narrow field mode, as I said, is only coming. Hopefully, we're going to have that done by July, August this year, and then it will be offered after that to the community. So that will be much smaller, but it will use those 4 laser guide stars with extreme accuracy, and it's going down to 650 nanometers with a goal of about 10% strail. So that's actually quite amazing. So all of a sudden you get an 8-meter telescope that gives you 10% strail in the red. So if you then list all the instruments that we are talking about that are supposed to be coming, this is Luca Pasquini, who is the head of the instrumentation program for Paranal, gave me that list. Then you see what we're up to. So gravity is happening right now. As Henri told you, the star S2 is now getting close to the black hole, the massive black hole at the center of the Milky Way. Actually, I think 18th of May is the date. So we're all a bit nervous about this. So gravity will be measuring that with extreme accuracy. Nobody else can do this. And if they do it right, they will show whether Einstein was right or wrong in the strong gravity regime, which is quite spectacular. Espresso is a new spectrograph coming. I'll show you some of this. I'll show you some of Matisse. I'll show you a little bit of Eris I go through all these instruments. The force upgrade is something that we've just started. I think I have a slide on this. CUBES is a UV high resolution spectrograph, which we've been talking about for years, but we never had the funding to do that. So Luca is trying to be creative on this. And then I have something to say about a new AO instrument that we're thinking about, which would be an AO, optical AO imager and spectrograph. Okay. All right, let's go through these instruments. This is similar to Henri's thing. These are now dreams. No, they're not dreams. Some of this exists, but we don't have the science results. I can't give you the science highlights as Henri did. So here's the Echelle spectrograph for rocky exoplanets and stable spectroscopic observations. This is a Swiss instrument, so it's a Swiss acronym in English, whatever it is. Espresso, super stable, high resolution, high throughput, fiber-fed spectrograph that takes essentially the light from all the UTs into one place. So you can use it either with one single telescope and you just have that fiber go into that instrument, or you can use all 4 telescopes. I've put this up here, so you can use all 4 telescopes as a single telescope and have 4 fibers go down to Espresso and have essentially almost a 16-meter equivalent telescope. That's what's described here. It has a fixed spectral range from 0.38 to 0.8 microns. A resolution, I mentioned this before, 120,000 to 220,000 in the 1 UT mode. It can use the 4 UTs then with a 60,000 resolution. And the goal here is to measure 10 centimeters per second radial velocity. This is, as you all know, this is much slower than we walk. Okay. Walk carefully. It's in commissioning, so it should be offered with period 103. Matisse is a VLTI, an interferometer instrument, just to remember us. It's called multi-aperture mid-infrared spectroscopic experiment. It's an instrument, it's not just an experiment. It will use all 4 telescopes in L, M, and N band, so that's going all the way out to 5 to 10 microns. It will have multi-axial beam combination, closer phase imaging, 4 telescopes, and spectral resolution from 30 to 5,000. Again, with all the VLTI instruments that we have, we can use them either with the movable 1.8 meter telescopes, or we can use them with the 8 meter telescopes together. That's in commissioning. That's arrived on the mountain, and they just started commissioning a month ago. CRIRES is an instrument that we had on the telescope some years ago, an infrared, high-resolution infrared spectrograph, which turns out the spectral coverage that we had, the instantaneous spectral coverage that we had, was so small that the instrument was difficult to use. Let me put it this way. So it was decided to bring it back and have a cross disperser mounted into it, so we have now a much, much wider spectral range in one shot. And so that's what's happening right now. This is an image from the technical building just across here from us probably many weeks ago, quite a few weeks ago. This is the vacuum vessel. They all look like this. Vacuum vessel is closed. And so it's being tested right here, right now, sorry, and it goes to Chile in October or November this year, pretty soon. It has a coverage of 1 to 5 microns at the resolution of 20 to 100,000. Cross disperser, as I said, new detectors in there. So we have a much higher spectral coverage, wavelength coverage. It has gas cells to get accurate radial velocities. It has some polarimetry in it. And it also will have an AO system, adaptive optics system, just to correct for the input. ARIS is an instrument, excuse me, that image just flipped sideways. It doesn't matter, you just have to think the telescope is now pointing down. So that's okay. Anyhow, it will use an existing spectrograph that's now part of the Symphony instrument. So we will dismantle Symphony, bring that back, and take the spectrograph out of that and move it, build it into ARIS. We being, in this case, the Max Planck for extraterrestrial astrophysics, who's doing this instrument. So it has various essentially different lenses, if you want, magnifications that offer fields of 0.8 arc seconds on the side, up to 8 arc seconds on the side, and spectral resolutions from 3000 and 8000, and it covers J through K. Okay, it consists of, as I said, a spectrograph up here, SPIFFY, and a camera, which is called NIX, near infrared. I don't know where the X comes from. So again, J through K with narrow and broad bands, and different magnifications, different pixel scales, and L and M band as well. And it will have high contrast imaging, pupil plane coronography. It will have focal plane coronography, sparse aperture masking. All of those things, many of these things we've offered with NACO. This will be a much better system than NACO is right now. We'll have some long slit spectroscopy, and we do hope that we will offer this by 2020. The goal is to bring this to the telescope early 2020, first half of 2020, and then be offering it after that. Moons. So the next two instruments I'm going to talk about are multiplex, high multiplex spectrographs, working with fibers. I think that's a fiber one too. Moons goes to one of the 8-meter telescopes, one of the UTs. It has a multiplex of 1,000, and some of them can be deployed in pairs. That has to do with the sky subtraction. Has a rather big field of view for an 8-meter telescope. The 4-meter telescopes, many 4-meter telescopes have larger field of view, and since I know that the Australians are listening to this, I'm aware of what I'm talking about. So it will offer two resolutions, a medium resolution 46,000 mode and a high resolution mode that can go up all to 20,000. And as you see here, the coverage is from 0.6 microns, 6,500 angstroms, all the way to 1.8 microns. Okay, so that's what we're hoping there. And again, this should actually go to Paranal next year to be offered in 2020, maybe 2021. The other instrument that's being developed right now is called Foremost. This is a very massive multi-object spectrograph which works in the optical, and it will go to the VISTA telescope. So this survey telescope that we right now use to do infrared imaging surveys will be refurbished to take this spectrograph. Here's the fiber positioner, which sits behind the beam comes in here, so it sits behind the primary mirror, and then you have two spectrographs mounted underneath. Here's one, and there's one on the other side, the high resolution spectrograph. Large field of view, more than 4 square degrees. It will have spectral resolution in the low resolution mode of 5,000, high resolution mode of 18,000, and the high resolution mode is mostly for the galactic, so this is inverted galactic applications, and the low resolution mode for extragalactic applications. High multiplex, I think I mentioned that. Broad wavelength coverage, essentially the whole optical, and it will, as I said, go to VISTA. This will take a little longer, so this is now having a date of 2022, hopefully. Adaptive optics, the visible adaptive optics instrument. This is something that we're going to announce very soon, that we would like to build an instrument that does visible adaptive optics. Now, this sounds a bit funny. Nobody else. Not many places do this. Gemini has a possibility to do that, although it's not used that much. So we've discussed this in various fora. So I've talked to quite a number of people what the right thing would be, and the most attractive concept that we came up with is a visible multi-conjugate adaptive optics system. So you would actually correct different layers in the atmosphere to do that in the optical, which nobody has done so far. So we will issue a call for phase A studies, hopefully in a few weeks, very soon. We have built science cases. We have the top level requirements so that everybody knows what we actually would like to have in that instrument. We do have a strawman concept for the AO, for the adaptive optics, and the management plan. So the bottom line is, for me, it is we would like to maintain the capability that we right now have with HST, these images that HST is delivering to us in the optical. We would like to maintain that capability because HST will stop working in a few years. And if we at ESO can provide, we won't have the same field of view as HST because we have to correct the atmosphere, so we can't do that. But if we can have an optical imager, maybe a spectrograph with it, that gives us a similar resolution, spatial resolution, angle resolution, as HST gives us now, I think that will be, I believe, is a winner, but I've been pushing for it, so I'm biased. And it will have very strong synergies with the ELT. As people pointed out, the diffraction limit on the ELT, on the 40-meter telescope in K-band, is the same diffraction limit as in the visual band on an 8-meter telescope. So if we pull this off, we can actually we can provide the community with imaging quality that's the same all the way from the visual. I'm cheating a little bit, but essentially the same from the visual all the way into the K-band. And I think that would be very, very, well, I believe that's very attractive, so that's why I'm pushing for it. These are specifications. I don't want to go into this. Now, Force 2 is a different, the Force 2 upgrade is a slightly different story. We have an instrument, as Henri told you, a workhorse instrument's been doing, call it the Swiss Army knife of the VLT. I'm with you. It can do many, many different things, but it's been hanging on that telescope for 15 years, at least 15 years. And we've done nothing to it, okay? Now, if you have a car that's 15 years old, you will know what that means. And so what we need to do is we don't need to fix the instrument, but we need to bring it into the 21st century, okay? And so what the goal of this upgrade is to make sure that FORCE will be working another 15 years, hopefully 20 years, and do the best as it can. And so that's why we're working on this. Henri knows this very well. It's been requested for a long time by him and the instrument operations team. So we will put in a new CCD to essentially have the full wavelength coverage. We don't have to change cameras as we do right now. We have hopefully maximize the operations efficiency and various other things. Now, an important scientific point, which we didn't bring up, something that we don't advertise that much. If you bring new instruments, you have to take old instruments off, okay? Because there's only so many foci that we have. Now, we've been in the luxury situation that we always had another foci still available, but now we've reached a point where we actually have to take something away to make space for a new instrument. And in a long discussion that we had with various places, we decided to take VMOS off, which is an optical high multiplex spectrograph. And so we're taking this off, and that means that FORCE, which has a similar capability though on a smaller field, becomes more, the science case for FORCE becomes more important again. And so that's another reason that we need to maintain that instrument for a while. We're starting with this right now. So hopefully we'll have an accelerated schedule on this, and maybe 3 years, 4 years from now, we have a new FORCE. Not a new FORCE, we have a refurbished FORCE. So the UV spectrograph, again, I've taken this from Luca Pasquini. This is something that we have in the pipeline. We haven't started working on this. As I said, we don't have the money to do this right now. This would be a spectrograph that's very specific in the very UV between the atmospheric cutoff at 300, 310 nanometers to about 380, maybe 400 nanometers. It's a very narrow range, but it's a very critical range for many of the spectroscopists. That's something that we don't have very good access to. And so there was a workshop 5 years ago already. So there was a workshop here in this room to discuss this. And there are complementarities and synergies with ELT. Hopefully we can get going on this maybe next year. That's what Luca's plan is. So in 4 years from now, we hope that Paranal looks something like this. So in light blue are these instruments that will have been, so light blue are the Cassegrain instruments, but we will have For the interferometer, we have 3 instruments that will be going fully commissioned, doing great stuff. Pioneer, Gravity, and Maltese. We will have Espresso, which is sitting down here in that hole, which will be making use of the combined focus, the incoherent combined focus. Vista with foremost, and we have the 4 laser guide stars now. So far we've been offering only 1, now we will offer 4. And let me tell you, it makes a big difference whether you have that one diddly little laser that you hardly see when you're there, and these 4 lasers that you cannot miss when they're shining up. I mean, it's spectacular, I have to tell you. So we will have some real power in the sky with this. With Eris here, this is mostly unchanged. Well, Cryres Plus is coming. This is the upgrade of Cryres. This is essentially unchanged, and you have moons here and foremost here. I mentioned that. Okay, so that's the hope that we have. I'm not quite done. I have a couple of more things. I told you that we try to think a little bit into the future. And some years ago, I was asked to think about future strategies for optical infrared astronomy. And so I tried to sit down and think what are the important things. So I think this is what I came up with. I think flexibility is a very important feature of future observations. We have a transient sky, many things in the sky change. Most things don't change, but many other things do change, and we need to be alert that we can observe those things. So we need flexibility in topics, in techniques, in instrumentation, and also how we react to things. We need coordination. We need to be able, and ESO is in a unique position that we can offer our community many different instruments. Okay. If you need full wavelength coverage, you will find instruments that can help you observe your object in all those wavelengths, which is not every observatory can do that. So we have to make sure that our instrumentation programs are versatile in this, either through a large pool, as I say here, or maybe you collaborate with other observatories. That's another option. There's something that we work on, on a political level, the better planning between ground and space. So if Euclid flies, what do they need from the ground? What ground-based observations do they need? Plato, similar story. Espresso, for example, has been specifically, not only, but specifically also built to follow up Plato targets. And then time allocation between observatories. And operations, so we have what we believe, we have inbuilt flexibility through the service mode, which offers you things that other observatories cannot offer you. And then, as I said, we have a large archive. La Silla. So we didn't talk much about La Silla. I already told you what's available there and what we're doing there. So the goal, the idea on La Silla is with the 4-meter telescopes. And this is something that the Australians have done over a decade ago, probably 2 decades, or almost 2 decades ago. You dedicate your 4-meter telescope to a specific function. Okay, and so what we're thinking of doing, well, actually, I think what we are doing is we're dedicating the 3.6-meter telescope to exoplanets and radio velocity studies. What does that mean? That means we have instruments on that telescope that are the best in the world to do that specific thing. HARPS is the best high-resolution, stable spectrograph that there is, we believe. It's a bit older. There's some copies of HARPS that are as good or better, but it's still doing very well. And we're building, the community builds for us a near-infrared spectrograph that does the same thing. So we will have optical and near-infrared, high-resolution spectrographs, stable spectrographs to measure exoplanets, the radio velocity changes in the stars, and the NTT, we believe we should dedicate, and again, already showed you this, with PESTO, we have a program that is following up transient objects. And so we hope that with the NTT, well, we hope, that's what we're doing. So we have EFOSC and SOFI right now. We do offer UltraCam on a temporary basis. I'm not sure whether we offer it for the next period. I don't get any reaction, so I don't know yet, but UltraCam is a very high time resolution camera. And again, the community is building an instrument called SOX. So like Sophie is the son of Isaac, but you never would name your son Sophie. That's the thing I never understood. Okay, different story. So to get away from this, the son of X shooter is SOX. Okay, I'll leave that up to you. So SOX is an instrument that's going to come to do essentially the same thing as EFOSC and SOFI do right now, but there are two instruments, and SOX will be one. It's like X shooter, a spectrum in one shot. Okay, so that's the idea, and this consortium has a large plan of following up transients. There's so many transients in the sky. Apart from gravitational wave events, there's many other interesting things. Now, we have a number of other telescopes operational on La Silla. These are, we call them hosted telescopes. These are for specific experiments. They're privately owned. Okay, they're not our telescopes, and we do not offer time there. So they're not there. And so that's actually, see, I'm outdated here. So these two have to be moved over here because they're operational. So here's a picture, an idea of NIRPs. All these high-resolution, stable high-resolution spectrographs look the same. There's the optics in here on an optical bench, and they're sitting inside a vacuum vessel, essentially, which is temperature controlled. So NIRPs will be at 3.6 will be working from essentially 1 micron to 1.8 microns at a high resolution of 80,000. It will have some AO assistance to essentially to stabilize the image. And you can observe at the same time as HARPS. So essentially, you then have a coverage. HARPS goes from, I guess, 400 nanometers or something like this. So you essentially can have a coverage from 400 nanometers to 1.8. It's like an extremely high resolution X shooter, okay, 80,000 X shooter. And the goal here is that the radial velocity, this should be a delta radial velocity, will be less than 1 meter per second. SOX on the NTT is again covering from 350 nanometers to 2 microns. So that's like X shooter covering a large wavelength range. It will have sort of spectral resolution that reaches from 3,500 in the blue to 6,000 in the red, I believe. 2 arms, UV visual plus a near infrared arm, and this, well, will hopefully have a high throughput. It will have a small acquisition camera just to have quick photometry to make sure that you have the brightness of the star. All right. Sure. You need the microphone, otherwise people can't hear you. Sorry.
Much higher than we now have with EFOSC2, right?
That's right.
That's a problem.
That is true. So you won't have the low resolution. You just have to rebin, integrate longer. It's okay. Well, you have. I mean, you have an 8-meter telescope if you need. If you need if you need to observe fainter objects. Sorry. So you don't have. That's true. You don't have the low resolution. Forest is offering you a low resolution mode of 800, for example, at the VLT. We're not losing that capability. Okay, that's my last slide. That's just sort of a summary where we're going to go now. So this year, April this year. So this is the call for proposals this year. Not only the call, but VMOS is going to be decommissioned. So we have another 3 weeks to go on VMOS. Oh, I see some smiles. Sorry. So VMOS is going to be decommissioned. I hope we finished all the surveys. Did we? Good. Okay. So we're done with VMOS. Again, the reason we're doing this is not because we don't like it. The reason we're doing it is we need the focus to put in a new instrument. In this case, CRIRIS, the upgraded CRIRIS. Okay. Espresso is offered in the call for proposals with the 1 UT mode. Half a year later, you will get the 4 UT modes. And gravity, now I'm confused. Well, yeah, gravity is offered. It's in the call for proposal. I thought it's the imaging. Maybe the astrometry is only partial. Then next year, as I said, next year we'll have Espresso with 4 UTs. We will have Matisse with the UTs and the unit telescopes and the auxiliary telescopes. We will have Muse narrow field mode offered next year. We'll finish it this year. And we will have CRIRIS, the upgraded CRIRIS next year as well. So that's coming next year. And then after that, we will have NIRPs, Eris, and Moons. And I stopped there because I don't want to make promises that we we may not be able to keep. But you've seen all the other instruments. We have plenty of things in the pipeline to come in the coming years for VLT and also for the Silla telescopes. Thank you very much.
Thank you, Bruno. The reason I was smiling is not because I don't like Venus, but I like better Critus.
Yeah.
So, question? Yes, please.
As far as I catched up, you mentioned polarimetry only with Critus. Maybe some other instruments will also have polarimetry capabilities.
Right. So we already offer polarimetry with force. I'm not enough of an expert, so we do imaging polarimetry and spectra polarimetry. Critus will have some polarimetry. HARPS has polarimetry in it. Somebody help me. Sphere, thank you.
But from new instruments.
So, oh, the new instruments. So the upgraded force will keep the polarimetry, I'm pretty sure, and Critus Plus. So the upgraded Critus, and HARPS is going to be there still. So there's, I think we're covering a fair fraction of the polarimetry. It's one of those things, I haven't shown this, but we are able to track what you guys ask, what the community is asking for. And I mentioned this morning. I mentioned this in my first talk with the high resolution time imaging mode, which we discontinued on force because nobody asked for it. And so if we have many people ask for polarimetry we keep anyway because it's an important technique that we need to offer. But if there's more demand, we'll have to make sure we offer it maybe in more instruments. But right now we do cover the high resolution spectral polarimetry. We have some imaging spectral polarimetry on an 8 meter, which actually, as far as I know, is the only 8 meter that offers that capability at low resolution as well. And so we believe we offer, right now we believe we offer enough. If that's not enough, the community needs to speak up. We listen.
Now I would like to ask about Force 2.
Yeah.
So you say it's going to be upgraded, right?
Yes.
So it will not be available for some time, right?
That we're discussing how that exactly is going to work. We will make sure that it will be available as much as possible. It will not be off the telescope for years. Okay. I can't tell you exactly how long it's going to be off the telescope, but it should be as little as possible. Okay. We're fully aware of that problem.
More hypothetical question. So Espresso has some kind of a fiber connection to the UTs, right?
Yeah.
And which is not taking the foci.
Which is
not taking any of the foci places.
Right.
So why not putting Critus in the same way?
So there is talk. So there's a number of ideas that people are playing around with. One of them is to have a fiber connection from sphere to Critus, because there you can make use of the adaptive optics and then have a high resolution spectrograph for exoplanets. You can immediately see why that would be a great thing to have. Espresso is sitting in a very specific place on the mountain. Let me see where I can show you this. Espresso sits right here in the center. Okay, so it's much easier to get a fiber from here to here than taking a fiber. Actually, it would be terrible because you probably would have to take the fiber to here and then out to here and then back up again. And by that time, you've lost a lot of light, and it's not sure whether that's worth it. So we haven't considered that, but people have asked to have sphere, for example, connected to Espresso or sphere connected to Critus. So these are ideas that are floating around. There's other crazy ideas that think of. One of the things that we will do next year, hopefully, we'll organize a workshop here at ESO to talk about the future of the VLT. Where, apart from these things that we're doing already, what are the big things that we should think about in the future? And so a year and a half from now or so, we'll talk about this with the community.
Any further question? Online? Is there any question from people online? No, it seems not.